This video is going to be about how Amazon develops and deploys code for their applications using CI and CD pipelines. And so a recent article on the AWS Builders Library was just released that documents this entire process. I'll put that in the description section in case you want to check it out. I've also worked at Amazon myself for almost a decade now, so I have quite a bit of experience in terms of how things are set up and how the process works. And I just want to add that the CI/CD pipelines that we have set up that we use for all of our services are extremely efficient and make it so that you're not getting blocked on feature releases where you have large gates where multiple features get released all at once. It's a very seamless experience where you make a change, you push it, and then tests run, and you of course get that into production. So it minimizes risk while at the same time keeps you very speedy in terms of developing and releasing new features. And I think that these types of pipelines are things that other companies can strive for because they truly offer a lot in terms of making you quicker to get your code out there. And so in terms of what we're going to talk about here, so I first want to talk about how we develop applications, so how we actually set up our code structure using Git. And then I'm going to talk about the pipelines themselves and how those are set up, all the different steps that are in, the different environments that we have set up, and give you a little bit more breakdown there, and also talk about some different options that are kind of dependent on the type of service that you have as well. Okay, so let's start with the Git setup. Now, I will say that the Git setup, I can already tell you, I'm probably going to get a lot of flack for this, but don't blame the messenger here. This is just how things are set up and how people do it. Some other teams or some other companies may have different setups, so don't kill me here. So they use what's called a trunk-based development style for Git. So what happens is, say there's like a service in place and you have a bunch of different software packages that are related to it. You have your typical Git stuff where you're making changes over time. So you have 3 different commits here. And so say you're a new developer and you want to make a change, so you want to add a new feature. What are the things that you do? So your first step is you want to pull the most recent version of the code that was deployed on the remote branch. And so you pull this and now you're kind of working on your stuff on the side here, right? So you're making your changes, you're doing stuff, maybe you're doing some small intermediary commits as kind of checkpoints to mark that, you're making progress here. Now say that you've made all these changes and you're basically ready, you've tested everything out, you wrote your test for it, all that kind of stuff. You're ready to push this and you want to kind of commit it, right, to mainline. And so what happens is that, you have 3 different commits here. And so you don't want these 3 commits to actually be merged into mainline as 3 separate commits. So what the convention is to squash these into one single commit. So I'll just put like a shaded one over here that represents the kind of squashed commit. And then you want that commit to be the one that is kind of looked at by your reviewers and eventually make it into mainline. And so what you do at this point, once you're done developing, is that you'll again pull changes that exist on the mainline branch before you attempt to get what's called the code review, which I'll talk about in a second. Because remember, there's other people, like there's people over here that could be making changes in between the time that you were doing stuff over here. So your mainline, your remote mainline could have diverged quite a bit. And so what you need to do is when you're over here on your remote branch or on your local branch, you need to pull in the most recent ones. And so you'll pull in, you'll rebase on top of whatever already exists. You'll resolve any conflicts, and then you're basically ready to start getting what's called a code review. And a code review is just a kind of a second pair of eyes that need to look at your code. They kind of take a look at what you've done. You explain kind of, this is what this commit is for. These are the tests that I wrote for it. This is why we're making the change. Here's the link to the intake request or what this is related to. Here's the different test cases that are run against this. Here's the manual test cases that I've ran as well. Anything really that the reviewer needs to know in order to efficiently take a look at your code before they can review it and approve it. And so what'll happen here during this process, so like at this point, there's like another person. Usually it's like a couple people as well. It's not necessarily just one person. This really depends on your organization. You'll put out this CR, right? So you'll like publish using this internal tool. So you'll put out this CR. This person will get notified. They'll take a look at it. And there may be like a couple rounds, right? So like you have your code here. The other person looks at it. They look at it. Oh, there's something wrong. They publish comments. And so they say, oh, you should fix this and that. So then you do it again. So you have a second commit. You CR that as well that addresses their comments. It's a very kind of fluid process, and it's not very uncommon to have like 2, 3, 4 kind of revisions on your CR to get it right. So this is not an uncommon thing. Now, after all of that happens, you eventually get kind of an approval or a ship it. So you're ready to finally push this into the mainline branch. And so at that point, the CR ID, or the commit ID, I should say, gets associated with the CR ID. So you have this separate system that's all about CRs. You have this, obviously Git system that's all about your commits. There's a linking that happens there. So every commit has a approval either associated with it or not. Now, in order for it to get through your pipeline, which is at a later stage, there's a check that occurs to ensure that each of the commits that are pushed to mainline have a associated and approved code review attached to them. So this is the way that we prevent these bad changes or these like kind of manual things where someone's gone rogue and made a bunch of changes without telling anyone. This is how they get prevented from getting into your actual deployment cycle. And so after all that is done, like someone has reviewed this, so you're ready to like merge back in. So you just do that. And since you already have the most recent version of the code because you kind of pulled it before you did the approval, then you'll just kind of push at that point. If anyone in between that period of time, anyone makes other changes, you'll just pull and rebase on top of that again, and you just kind of make the change after that. So that's how that works. So at the end, you get your change here, and then kind of it kicks off the pipeline process. So this is what we call, or what is called trunk-based development in terms of Git workflows. You may have an opinion about this, but this is just how it works. So you've now made your change and you're ready to get this thing into production. So what does that life cycle look like? What does that pipeline look like? So let me just scroll down here to make a little bit of space. All right, so now you made all your changes and you're ready to deploy them. So you push your commit. And so what happens now? Now we're in the domain of the pipeline itself. And so in any pipeline for any service, say you have like, I don't know, order service is what we're going to be calling this one here, order service. And the whole purpose of this is to take orders, for example. And so in this service, you have your source code that we just kind of talked about here, where you just made your fresh commit. Now, one thing to keep in mind is that, there's multiple different packages that can exist as part of your source code. So package 1, this is maybe the one that you made changes to. There could be some other direct dependencies that you need. That could be package 2, package 3. There's all sorts of packages that you may have a direct dependency on in order to successfully build like an executable that can actually make it into production and can start up as part of your service. And so you just made changes here to package 1, for instance. And so this is connected to the Git repository such that anytime any changes are made to these different packages, it triggers a build in this case. So that goes to the next step here, which is called the build step. And so the build step, this is all about actually compiling your code, right? So building it and then running all the unit tests that are associated with it. So unit tests. This is also where things like code coverage percentages can get checked. So code coverage percent. So if you have, a testing requirement that's like 90% of new code needs to have unit tests associated with it, that's where you can enforce this as well. You can also make it so that if it doesn't have a approval as part of the commit that just triggered this rebuild, then reject this whole thing. And so there's a bunch of different checks that can occur here. And so this is where you can also do things like static analysis as well. So you can check for like anti-patterns in your code or certain cases like that can cause memory leaks, things like that. This is also very effective to catch things in advance. Now, in addition, I just wanted to point out as well that stuff like linting and check styles and violations of those types of things are also being done here. But typically that's also done as part of the development process itself. And that's baked into the IDE or the integrated development environment. And so that is done in two places, both on the worker's machine or on the SDE's machine, and also during the build step itself. So these two things get enforced in two different places. And so assuming all of this is successful, if any of these things fail, then this whole thing just pauses and the person needs to come and either override it or fix it. If you override it, it like triggers an email or something, like people will know and you won't look very good. You better have a good reason for it. But you can override it, or if it just succeeds, then you just move to the next step. And so this was the build step here. And so after this is where our first kind of deployment environment exists. And this goes to a place called beta. And this is kind of like the wild, wild west. Every different service across your organization has a beta environment. And this, the expectations are really low here. So say your service depends on another service. So like your order service calls, I don't know, payment service, for example. it's not really guaranteed that payment service in their beta environment will be up and running. So things are really flaky over here, right? So it's not really kind of safe to assume that, you call your API that has a dependency on something else. It's not safe that it's going to work all the time. So you need to be careful here. Sometimes you mock dependencies if you're doing functional tests here, which is actually something I want to add. So here's where you typically do your functional test to ensure that like things are working just correctly. You're able to start up the server. It's working correctly. You can ping it. It's responding. You do some sanity checks on your API. Maybe you call other dependencies, but you stub the responses or you mock the responses. You can do all those types of things here. But again, this is an environment that's shared across all other teams as well that have their own services. They also use a beta environment. And when you deploy your service to the beta environment, these are all kind of wired in such a way that my beta talks to your beta talks to another person's beta. It's kind of scoped to the right environment. And when you deploy, it knows where to look. And so assuming all of this is successful, so you deploy, it starts up, you do your ping checks, you do your health checks, you succeed with your functional tests, then you can go to the next step. And as you move towards the right here in this diagram, things are progressively getting more and more stable. They're becoming more and more production-like. And so then we move to the Gamma environment. And the Gamma environment is one where it's much more stable. People generally have their things together. The services that you depend on are more likely than not working. If it's not, it's kind of a rare case. You can reach out to the other team like, hey, something's not working. Our tests are failing. What's going on here? And they'll more likely than not fix it. And so here you can run more robust testing. So you can do things like integration tests to ensure that you're able to integrate with any of your dependencies. You can also do things like end-to-end tests. So you can do scenario-based tests like, create some data here, put it in a database, put it in that service, trigger one of my APIs. It should do this, this, and that. All of these things should work in this environment. And again, all of this is automated. All of this is happening automatically. There's no manual approvals here happening at all. It's all just running through the system as it is set up. And of course, like you need to run or you need to create these, right? You need to write the integration tests. You need to write the end-to-end tests. You need to write the functional tests. All of this stuff is up to you to write. There's no QA person that does this for you. This is all part of the software development engineer or SDE role or responsibilities. And so Amazon in general is very light on the QAs, except for some kind of UI based teams. But you'll find that, you're an owner here in terms of the code that you write, in terms of its functionality, and in terms of all the tests that you need to write around it to make sure it's doing what it's supposed to do. And so assuming all of this works correctly, like Gamma's working, all your tests pass, they all run, good to go. Then you can move to kind of the production part of this. And so let's scroll to the right here to make a little bit more room. Okay, so this is where things to start getting a little bit more interesting. So there's actually two different stages here, and I'm going to keep this simple. We're just going to talk about one region right now, right? So in AWS, say this is for like US East 1. This is our production environment. I want to keep it simple. We're just going to be talking about one regional stack. We'll talk about other regions in a second here. And of course, like we're talking about prod now. And so there's two separate ones here. So I'm just going to put these dots in and then we can fill it in. And so this one over here, it's one that's called OneBox. And this one is our fleet deployment. And so what happens here is that assume that you're running your service on something like EC2 machines, for example, right? So say you have like 3 different EC2 machines that are all hosting your service, or say they're like Fargate, TASK, whatever it may be, it doesn't matter. And so what happens is that, obviously, first of all, a lot of the services that run on Amazon use a lot more than 3 machines. So this is already not very accurate. But what happens is that in the OneBox environment, what do we not want to happen when we deploy an application? Like we don't want to deploy our application to all of these different instances here. And then like, oh, by the way, there's something you missed in terms of your tests over here. And now everything is busted. Like all the APIs that are coming in are all failing because, you deployed to everything in the beginning. So this is what you don't want to do, right? And so the way that Amazon kind of mitigates risk here is they have this concept of OneBox. And so what happens is you have this like 4th machine over here that's not part of the fleet, right? The fleet is these 3 machines over here. So F, 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 and this is OneBox. one box. And so what happens first is that you deploy to this one box instance, right? And so this gets deployed with your new code. So now you have two versions of code. You have what's happening already on the fleet. That's what was there before. Now you have your new code over here on one box. And so what happens here is, from a risk mitigation perspective, this is a genius idea. This is also called like a canary deployment, by the way. There's other names for this, but this is a genius idea because it allows you to see, like, is my thing working correctly? Traffic is hitting this one box instance as well. It's not just hitting your fleet. So it's hitting all the different hosts that are in your environment, both one box and fleet. But in addition, you also have alarms that are set up on this, right? Alarms that are set up on your one box environment. And so if anything breaks, like there's a high level of errors, high level of latency, anything is abnormal here at all, there's an auto rollback that occurs. So this thing just goes back to the previous instance or the previous code that was in the previous environment. So Gamma in this case. And so this is how they kind of mitigate risk here so that we're not deploying all of this new code at once and just blowing up the entire service all at once. Now, if you think about from a blue-green deployment perspective, that's like where you set up like a blue-green deployment here as contrast. If we just draw a line here, is you have like your existing fleet, then you would deploy your new code onto like 3 separate machines, and then you would like flip a switch and everything switches from this, and then everything is on here. This is blue-green deployment, right? This is risky, right? Because now all of your customers, all your clients are all getting the new behavior of your brand new code, and it could be broken. And so this is why this approach is used, because you can progressively introduce changes here, and you can roll back very quickly because it's just one instance at the end of the day. Now, there are cases where things slip through and like you get to fleet, but more often than not, you catch things in this one box approach prior to hitting the fleet. Okay. And so here on one box, like I said, you have all these alarms. So alarms, you have dashboards that are being monitored as well. But like in a CI/CD pipeline, no one really looks at the dashboards until things are broken because, you know, you have alarms pretty much on everything, like error rates, latency, exceptions, health checks, too many hosts taken down at once to do a deployment, things like that. Like there's a gambit of alarms here that are set up. So you can be pretty confident that if anything goes wrong with this deployment, it's going to auto roll back and it's just going to kind of trigger an email for you to go and check out. And so assuming all of this stuff happens successfully, so no issues go on, so this is a success, this is where you do your final deployment, where it finally makes it to fleet. And this is where the code now gets deployed onto the fleet boxes, so on here. And so there's a couple different approaches that different teams can use in terms of actually deploying their new code onto their hosts. And so there's one approach that's called striping. And then there's another approach that's called like AZ based or availability zone based. And so let me actually just make a little bit more room here to talk about this more, which is that, say you have 3 different hosts here. They're all in different availability zones. So AZ1 is here, AZ2 is here, AZ3 is here. AZ3 is here, and like you have your machine here, you have your machine there, your machine there. These are different potentially data centers, could be like partitioned data centers in the same physical location, but they have their own like power supply, own internet, all that kind of thing. And so striping would mean that, actually, let's make this a little bit more interesting. Let's say we have 3 hosts in each AZ now, instead of just 1 in each, because I can't really demonstrate this well with just 1 in each. So striping, what that means is that you deploy 1 to 1 AZ. So this gets hit with a deployment, then this one gets hit with, or like these all happen concurrently. So you deploy to one, all the AZs at once, but 1 instance per. And so you also try and maintain 66% uptime, so availability for your service. So in this case, we lost 33% of our hosts, so we still have 66% uptime, so we're still good. And so after these are successful in these different AZs, then you go to the next one. So then you do this one, and this one all at once. And then again, at the end, once those are done, you do this one and then this one and this one. So you're only ever deploying to around 33% at the same time. And so this way you can kind of mitigate the risk of something happening in one of the AZs. And you can also ensure that your service has 66% of itself up and running. This does require you to over provision. So when you're deploying, you know, a third of your fleet is down. So this can be a problem if you don't have enough hosts. And so this is why there's a little bit of of over provisioning that happens, but this is kind of like a safeguard because if any AZs ever go down, you still have enough fleets, enough host capacity to service your service. So this is a good thing. So, same scenario as this, if this blows up, right? This is the same scenario as if I were doing a deployment. We still have 66% of the total fleet up and running here. And so this is why this over provisioning is a good thing. So this is just a normal run-of-the-mill deployment for just a single region. Now I want to make things even more complicated. Let's talk about when you have different regions now, because things are going to get crazy. And so say you have 3 regions now. So you have US East 1, right? This is your regional stack. Maybe this is for North America. You have another one like EU West 1, EU West 1, and then like AP, I don't know, AP East or like AP Northeast. I don't even know the Asia Pacific ones, but like say you have these, right? And so how does this work now? Like how do you deploy the same code to all these different regions in a safe way? And so in the production setup, what happens here in this case, and there's no right or wrong answer I want to say about this, but there are some good answers that I think like Amazon follows in terms of best practices, but this is how generally I've seen this set up. So what you have, like, and this is all production. Everything I'm going to write now is for production. Gamma is done, like Gamma is over. And so Gamma just ended over here, right? Gamma ended over here. And so now what'll happen is you need to kind of do region-based deployments, but you need to do it in a smart way so that you don't want to introduce a change that's worldwide necessarily. You want to be kind of very careful about this. And so you separate out your deployments into what are called waves. And so typically what you would do is first you would deploy for your production environment to the lowest traffic region, the one that has the least risk of things going wrong. So in this case, maybe it's AP East 1, right? So you would do AP East 1. I'm actually just going to call this AP E1. You would do AP East 1's one box deployment first, and then you would do its prod deployment first. So AP East 1, and then this will go to prod, right? So you would do this. So that would go like that. And so you would do these 2 deployments first. Now you can do multiple different approaches here. At this point, like assuming everything is going fine, you can do concurrently now the different production environments. So you can do your US East 1 and your EU West 1 at the same time. So US East 1 and EU West 1, EU West 1. You can also use their one box environment here. So do like one box first for US East 1, and then in parallel, do the same thing for EU West 1. This is really up to you and your tolerance for risk, but in a truly robust way, if you wanted to do this in a way that's as safe as possible, you would just chain these things together. So you would do AP one box, AP prod, then you would do the next most non-populous region. So say it's the EU region here, EU one box, right? And then EU prod, right? And then you would do kind of the next thing for US East 1. So US East 1, one box, and then US East 1 prod, US East 1 prod. So this is how you would set this up. And so if you have many more regions, you can either chain them together. You can also introduce some parallelization here if your appetite for risk is higher. One thing to keep in mind is that if you have an application that needs to be deployed to many, many regions now, this thing could take like a really, really long time. So in that case, you may want to introduce some kind of piece of parallelization here. And the tool that we have internally allows you to do this very easily, allows you to set up, these things are called waves, by the way, waves. So wave 1, this is wave 1 here. This will be wave 2, things like that. And it allows you to add like parallelization here. So if you want to do this in different regions all at once, you can do that. And this would just like deploy the code to the different regions. So very, very simple to set up, very straightforward, and it works really, really well. And so this is the basics of how Amazon develops and deploys their applications. Like I said, things are happening constantly. You're constantly making changes. They're going through the pipeline. They're hitting tests. The tests are being run. If it fails, it sends you an email. You need to go and fix it. If it succeeds, it's just hitting production. So things are constantly changing, allows you to be very, very quick with your development cycles and not have to gate a whole bunch of things all at once and deploy them in one big bang. It allows you to be very, very incremental. And so I hope this was helpful and gave you a perspective on how things are set up at some other companies. If you have any questions, let me know. And thanks so much for watching. I will see you in the next video.